Alright, so now we are looking at lesson C5, more multiplication property with exponents. Use properties with integers and exponents to simplify, and we need to know anything that the zero power is still equal to 1. So we're going to be doing some more problems and examples. Here's one. When you see something to the second power, what does that mean? It means that we're taking 4 to the 5th times another 4 to the 5th power. So we have 4 to the 5th times 4 to the 5th. What does that really mean in our expanded form? It means we should have 5 4s being multiplied times the second group of 5 4s. And we know from our work in yesterday's homework on C4, and we used our rule, if you have 5 4s and another 5, this would give us 4 to the 10th power if we are simplifying. So here is a shortcut when we have these powers that we are looking at. When we have powers, the shortcut is multiply, as we are doing, multiply the two exponents. So multiplying the two exponents to simplify. Now, this only works when we have a power to a power. So when I have 4 to the 5th, and notice that that was raised when we look at that 4 to the 5th was raised to the second power. So what we are looking at doing is taking 4 and taking 5 times 2, and 5 times 2 gives us 4 to the 10th power. When you look at the bottom notes, here's our essential understanding that we can use properties of exponents to simplify a power raised to a power. X to the 5th raised to the second really means x to the 5th times another x to the 5th. We know from previous that we would add our exponents, or we could now multiply those. So when we raise a power to a power, again, this would be another one you kind of want to work on and memorize. A to the m raised to the nth power means we can multiply our two exponents m and n. Here's a couple examples. Please take a look at how they did those, and we are going to start doing some practice and some more examples for you to practice to be ready for your homework tonight. Use the pattern we just looked to simplify. What is the simplified form of n to the 4th raised to the 7th? Key thing is, since we have a power to a power, we are multiplying 4 times 7, which now is going to be n to the 28th power. Let's try it with the next one. 4 to the 2nd raised to the 3rd. You're going to take 4, and we're going to take our exponents 2 times 3, which gives us 4 to the 6th. W to the 4th raised to the 5th. We are going to be taking w to the 4th times 5th. We're not adding these, we are multiplying, which gives us w to the 20th. Pause it if you need to as you're watching to make sure you have it written down. Replay it again to hear what we're talking about with these rules. So in problem 2, as we look at the bottom, we now have two different variables, so we need to be careful. We are going to rewrite this as m to the 2nd, and once we put our m to the 2nd, we then want to take a look, and the n has a power raised to the power. So we're going to put times n to the 3 times 2. You can either use a dot or parentheses. I prefer parentheses. So we're going to have m to the 2nd times n to the 6th. And a lot of times they won't write the dot in between those. This would be our simplified answer. We have no negative exponents, so we're going to keep our answer in this form. This next one, it gets a little trickier. As we are doing this, we're going to have x to the 2nd first, times, here we're going to take the 6 to the negative 4. Notice we don't take the 2 times negative 4, only what's inside that parenthesis, so that we're going to have 6 times the negative 4. So we actually will have x to the 2nd power times x to the negative 24. As we multiply that, remember, we are adding our exponents, so we end up with x to the negative 22, but we cannot have a negative exponent. Remember, that's over 1. So if we are simplifying that, our final answer would be 1 over x to the 22nd power. Again, let's take a look at this next one as we simplify. We have t to the second raised to the negative 2, t to the second raised to the negative 5. First, we're going to take t to the second times negative 2, multiplying those, to get t to the negative 4. Here we're going to have t to the second times negative 5, which will give us t to the negative 10. And when we add, we will end up with t to the negative 14. Remember, when you multiply the base, you add the exponents. T to the negative 14 is going to be written as our answer as 1 over t to the 14th power. Again, pause it, rewind it, so that you can see how to write this down. On the top of your next page of notes, raising a product to a power. What if we have more than one thing in that parenthesis that we're raising? How do we do that? So what you have to do, and you have to be very careful at this point, is that you take 4 to the third power times f to the second times the third power. Remember, that's not 0.3, that's 2 times 3. 4 to the third, you guys might remember that from your perfect cubes you memorized, 64. And now we have f to the sixth. Keeping in mind that this 4 to the third, what that really meant was 4 times 4 times 4. And our f squared raised to the third power really meant that we're going to have 3 f squareds. And that's how we ended up with 64 f to the sixth. Now at the bottom of this section of notes, they kind of talk about this important property. Again, a good thing you could put in Quizlet for raising a power to practice to make sure you're understanding this rule. But when anything to raise a product to a power, you raise each factor to that power. So notice here, a, b to the n goes a to the n and b to the n. And we are usually talking about n being a rational number. There's another example for you. Right now we're going to practice a couple more, and then I want you to try the last one before you continue. So as we start this one off, we would start with 7 to the third power, m to the 9th times 3. If we are looking at 7 to the third, again, some of you might remember that, that's going to be our 343, and if not, remember, you want to use your calculator. That might be this button on your calculator, or some of you have a y to the x. 7 to the third would give us 343. And then we are going to have m to the 27th for our solution. Oh, negative exponent. First thing I like to do, we can't have negative exponents, so let's rewrite it. This is going to be equal to 1 over that whole parenthesis, 2g to the 4th power. Now we still have the 1 in the numerator. We're going to take 2 to the 4th and g to the 4th. G was to the first, so 1 times 4 does give us 4. We now put maybe in our calculator, or we're going to multiply. 1 over 16g to the 4th is our solution. No negative exponents in our simplified answer. Please try this next one and pause the video. This is to the third power, each thing to the third. This is to the second, each one to the second. As I said, pause the video, and then when you turn it on, you'll hear my explanation and I'll help you get through it. So we have 6 to the third, a to the third, b to the third, times 5 to the second, a to the negative 3 to the second, 6 to the third. We're going to keep that, and then we're going to regroup our numbers. 6 to the third times 5 to the second. Again, you're going to be able to put this whole thing right in your calculator. Now we're going to group our a terms. A to the third was our first one, and this one we're going to rewrite as a to the negative 6, because we can multiply those. The last thing we have is a b to the third power. Now, we're going to put this whole thing in our calculator. 6 to the third times 5 to the second, and you should get a solution of 5,400. We look at our a powers. Since they're multiplied, we're going to add the exponents. A to the negative 3, b to the third. At this point, almost done, but we got that negative exponent. We got to get rid of it. 5,400 doesn't move, no negative exponent. B to the third doesn't move, no negative exponent. Just the A, and it is now to the third power for your solution. You are going to be working on your homework C5. What I would like you to do is you start off, you don't really have to show your work on these first ones, but when they start getting a little more complicated, I want to at least see when I get to number 4 that you have h to the first times maybe h to the positive 20 to get your solution. And then you're going to put h to a power. Again, here you might start off with a to the first times a, and you might show the multiplication. Someone asked, can I just multiply that and put a to the fourth and b to the eighth? Yes. Negative times a negative is positive. Oh, it looks like that's a 3, so I probably should have had a 6 here. And then I have b to the negative 3. And now you should be able to try and simplify from there. We'll be working on this assignment in class tomorrow, so please do not do the worksheet tonight.